Hello guys, so welcome back to another video of AJ classes. So today's question is prove that root 2 is an irrational number by the method of contradiction. We know that in the method of contradiction, first we assume the opposite of that given. So first we will do, let we assume that root 2 is a rational number. Root 2 is a rational number, and we know that there are what are rational numbers that are in the form of p by q. So let from this implies that root 2 is equal to p by q, where we know that q is not equal to 0, and let p and q have no common divisor. They have no common divisor other than 1. So let we assume this thing, let that root 2 is a rational number and it has in the form of p by q, where q is not equal to 0 and p and q have no common divisor. So from here we can find out, if you square both the sides, here 2 is equal to p square upon q square. If you both square upon both the sides, root 2 square is equal to 2 and p by q whole square is p square upon q square. So from here we can find out that p square is equal to 2q square. So from then again we assume that let p square is equal to even. We assume that let p square is equal to even. So from here we can find out that as p square is even, this implies that p will also be even. If a number square is even, that means the number is also even. So from here we can take let p is equal to 2k, and if you put this 2k value, then this implies that p square is equal to 4k square. We can find that p square is equal to 4k square. So from here we can find out that we already know this p square is called how much, 2q square. So this implies that here you can find out 2q square is equal to 4k square, or this implies that q square is equal to 2k square. So here what we find, this implies that q square is also even or not. We find out that q square is a multiple of 2 and k square, so that q square is also even, and this implies that if q square is even, q is also even, and we know if both p and q are even, that implies that p and q both are even. So this implies that they have common divisor 2. They have common divisor 2. But what we have assumed that both they have no common division other than 1. But here we find out that they have common divisor 2. So this way it's contradict to the fact. So it contradict to our assumption, that what is our assumption, that p and q have no common divisor other than 2. No common divisor other than 1. So other than 1 it has no common divisor. So but we find that they have common divisor 2. So that's why, so this implies what, our assumption is wrong. So this implies that our assumption is wrong, that we assume that root 2 is a rational number, and this implies that therefore that root 2 is a irrational number. So root 2 is a irrational number. So this is the proof of that root 2 is a irrational number by the method of contradiction. In the method of contradiction, first we contradict or assume the reverse one, means the opposite of this statement. If you like the video, then like the video and subscribe the channel for the latest videos.